Welcome back everyone, Patrick here. Moving on to the next question dealing with multiplying polynomials. So we have to find an expanded expression for the volume and surface area of a rectangular prism in each of these scenarios here. So both of these are going to be two different prisms. So in part A, we're told the length is 3 more than the width and the height is 4. And these could be any units, whether they're meters or centimeters. I just kept these unitless, so just as abstract numbers. And then in part B, we're told the length is 3 less than twice the width, and the height is 2 less than the width. So two different scenarios here. Let me, I'm going to erase this, just give myself some room, because we're going to be doing some diagrams here. So let's draw a rectangular prism for now. And let's just generally first talk about the formulas for a volume and a surface area. So the volume of a rectangular prism is going to be what? So let's say this is the height, this is the width, this is the length. The volume is going to be length times width times height, right? Just all three of those multiplied in whichever order. What's the surface area going to be? Let's actually, so I'll write the volume over here. What's the surface area formula going to be? Well, it's going to be the area of all 6 faces summed up. So notice that there's going to be 2 of each face. So what I mean by that is, let's say we're looking at the base first, so at this face over here. What's the area of that rectangle going to be? Well, it's just going to be length times width, right? This is the width, this is the length over here. But notice that there's another face that has those dimensions, and that's the top face up here, right? So there's 2 of them. So we'll have 2 length times width, right? That would be the area of these 2 faces. Now, what about this face over here? Notice that this face, this rectangle over here, it has an area of width times height. But there's 2 of them because this face on the end as well has that same area. So again, there's 2 of them. So we'll have 2 width times height. And then what's remaining? Well, the back face and then this front face over here. This front face has an area of length times height, right? This height here is the same. So we got length times height for this front face. That's the area of the front face and the back face, right? I can't really draw it here because this is all filled out, but it's basically that face in the back has an area of length times height as well. So there's 2 of those, right? So that's how you could break down the surface area formula. Another way you may see it broken down is you can actually take the 2 out, you could factor it, and what would be left is just the sum of those right there, length times width, width times height, and then length times height. All that summed up, and then you multiply it by 2 versus multiplying each one separately by 2. But for this particular video, I'm just going to keep this formula up here. But this is going to work as well. If you try it out, you just have to remember, because we're going to give an expanded expression for the surface area, you got to remember to expand that 2 back in. So since we're going to do that anyway, I'm just going to leave the 2 with all of those expressions, right? So just in general, a rectangular prism, that's the expression, or that's the formula for the volume, that's the formula for the surface area. So that's what we're going to be using. So let's start off with the first scenario. So let me draw a diagram again over here. So let's read this carefully. We got the length is 3 more than the width, and the height is 4. So the height, we already know, it doesn't depend on anything. It's just a constant of 4. And then we're told the length, so this over here, is 3 more than the width. And so what you want to do is you want to bring some kind of variable in here because we don't know what the width is. We just know that the length is 3 more than that. So let's, for part A, what I'm going to do is I'm going to let x equal the width of this rectangular prism. So that's going to be this over here, which means the length is 3 more than the width. It's going to be x plus 3, like that. Now you can also, you don't necessarily have to let x equal the width. Another possibility is you can let x equal the length. So let's say we did that. We let x equal the length. This one's a little bit less intuitive though, because now we're told the length is 3 more than the width. So it's 3 more than the width. So that means the width is going to be 3 less than the length. Right? So it'd be x and then x minus 3. You just have to make sure that whatever you use, you make sure that you state what you're using. We're going to be using this one, but you can also use this one. You don't have to use x either. You could use w for the width or l for the length. I'm just going to use x. So just make sure whatever you're using that you're stating here what you're using in order for your formulas to make sense and in order for you to get full marks. However, as I mentioned, you got to read these carefully. 3 more than the width. So the length, you could tell just from the wording, the length is based on the width. They're both based on each other, but just from the wording, it's easier to have the width as the variable, all right, versus having the length as the variable, because then you got to switch up the wording, right? You got to let x equal the length, and then the width is going to be 3 less than the length. Okay, if that was the wording, then it might make a little bit more sense to let x equal the length, right? But just from the wording, I'm going to let x equal the width, and then the length is going to be 3 more than the width, like that. And then all you have to do is really just plug these into these formulas and you'll get your expression. So let's start off with the volume. So the volume is going to be the length, which is x plus 3, times the width, which is x, times the height, which is 4, like that. And then to make this look a little nicer, usually if you have single expressions like this, you put them in the front and then you have a bracket. Like that, right? The x and the 4 we can combine, put it in the front, and then the bracket we could put on the end. But initially when you're writing everything out, I recommend just writing it out in this order, and then after you can rearrange it to look nicer. Now, they want an expanded expression. Notice this is a factored expression. So what we got to do is we got to take that 4x, expand it into the bracket. We'd end up with 4x squared plus 12x, like that. So that ends up being the volume, the expanded expression for the volume for this particular rectangular prism. Now, the surface area is going to be a little bit more of a tedious calculation. So let's go through these one by one. Let's actually, let's write these down. So h is 4. W is x, and then the length is x plus 3, just so we could have something to refer to. So we'll have 2 times the length. What's the length? It's x plus 3 times the width, which is just x, plus 2. The width times the width is x, and then times the height, which is just 4, like that. And then I'm going to continue this here just because I'm running out of room, so we'll have 2. The length is x plus 3, and then the height is 4. Right? That's the expression right there. It's not simplified, but we wrote everything down. So 2, length, width, 2, width, height, 2, length, and then the height. And then from here, we need to simplify all of this. So what I'm going to do, I'm going to combine the 2 and the x. Let's first make it look a little bit nicer. These we could just multiply because they're all just single expressions. 2 times x times 4 would give us 8x. And then this over here, I'm going to multiply the 4 and the 2, put that in front, and then we'll have the x plus 3, like that. And now we just have to expand everything, simplify like terms. So expanding in this bracket, we'll have 2x squared plus 6x plus 8x plus 8x plus 24, like that. And then the like terms, notice this, and that are like terms. So we'll have 2x squared plus 14, 22x. Like that. So that ends up being the expanded expression for the surface area, and we can't simplify that any further. And just doing a quick check, there's a lot of algebra going on here, so just confirm all your values here, and yeah, it looks good to me, right? So that ends up being the expanded expression for the volume. That's the surface area for this particular rectangular prism. Now moving on to part B, the other rectangular prism. So we're told the length is 3 less than twice the width, and the height is 2 less than the width. So this one's going to be a little bit more complex because notice before in part A, the height was a constant, but now the height is also going to be dependent on the width. So let's draw this diagram over here. Now, again, as I mentioned, the challenge is, the initial challenge at least, is figuring out what we're going to let the variable be based on. And again, in this particular question, I feel like letting x, or letting the variable, whatever you're going to use, x, w, or whatever, letting the variable be the width in this case again, because notice the length is 3 less than twice the width, so the length based on the width, and then the height is 2 less than the width. So notice the height is based on the width as well. So I feel like it just makes sense to let x equal the width, and then it's easier to make the equations or the expressions for the length and the height as well. If we let x equal the length, notice we're just going to have to rearrange the wording and kind of figure out in a different way what everything is. But I feel like in this case, it's just easier, again, to let x be the width. So let's start off with the length. So the length is 3 less than twice the width. So if we multiply the width by 2, it's going to be 3 less than that amount right there. So that ends up being the length right there, right? 3 less than twice the width, right? You got to read these very carefully. And then the height is 2 less than the width. That one's easy. It's just going to be the width minus 2, right? 2 less than the width right there. And then we have our dimensions, right? So in this case, we got the width equaling x, we got the height equaling x minus 2, and then we have the length, which is 2x minus 3, like that. Right? And so from here, because we have all of these in terms of one variable, we can now create these expressions. So let's start off with the volume. So the volume is length times width times height. So plugging these in, we'll have the length, which is 2x minus 3. We'll have the width, which is x, and then we'll have the height, which is x minus 2, like that. And then we just have to expand that. So I'm going to bring the x in front first, kind of rearrange this to make it look a little nicer. And then from here, different ways you can go about it because you're multiplying 3 things. You can multiply in whatever order. Personally, I'm going to keep the x on the outside for now. I'm going to multiply these 2 brackets, right? But you could also take the x, distribute it into this bracket, and then take that bracket, multiply it by this. Whichever way you do it, just make sure you're getting the same answer at the end. So multiplying these 2, 2x times x gives us 2x squared. 2x times negative 2 gives us negative 4x. Negative 3 times x gives us minus 3x. And then negative 3 times negative 2 gives us positive 6, like that. You could distribute the x at this point. I'm going to simplify the bracket first. Those are like terms. So that would be minus 7x, and then we'll have a plus 6 right there. Okay, and then from here, you could take the x, distribute it in the bracket. So we'll have 2x cubed minus 7x squared plus 6x. So that ends up being the volume, and then you can't simplify that any further, right? There's no like terms to further simplify. So that ends up being the answer for the volume. Now the surface area, I'll write out the answer over here. And then the surface area, let's actually just erase all this and use all of this space because it's going to be a more complex calculation. This was 3, right? Yeah. So surface area, it's what? What was that formula that we had before? Well, it's 2 length times width plus 2 width times height plus 2 length times height. Right? It doesn't matter which order you go in either because you're just adding. Right? So you could have like the 2WH in front or whichever order works. Let's keep it in this order for the video. So let's have some space here. So we'll have the length, 2x minus 3, and then the width, which is just x over here. Then we'll have the width, which is x, and then the height, which is just x minus 2, and then we'll have plus 2, the length, 2x minus 3, and then the height of x minus 2, like that. Right, so just be careful with writing out the original expression over here. There's a lot of brackets and stuff, a lot of different expressions for these dimensions, but it looks all good to me. So let's make this look a little bit nicer. The 2 and the x I'm going to combine. Same thing here. And then over here, we can actually, this is already in a nice format, so we can actually just start multiplying at this point. Let's keep the 2 on the outside, and then I'm going to multiply these two brackets over here. So we'll have 2x times x, which is 2x squared. 2x times negative 2, we actually already did this calculation, but a little repetition doesn't hurt. Right, so we end up with that right there. And then just to save space over here, we know that the negative 4x minus the 3x, that simplifies to minus 7x. So I'll just write that just so we don't simplify for the next line, right? And then from here, just expand everything and simplify. So we'll have the 2x that we have to distribute. So that would be 4x squared minus 6x. And then we'll have this 2x that we distribute plus 2x squared minus 4x. Right? And then we'll have, sorry, give me a sec here. Yes, we're all good. So over here, we'll distribute this 2 inside this bracket. So we'd end up with 4x squared minus 14x plus 12, like that. Okay, and then from here, we just have to collect all the like terms and simplify. So notice we'll have 4x squared plus 2x squared plus 4x squared. So that would give us what? 10x squared, so those go away. And then we'll have minus 6x minus 4x minus 14x. So this would be minus 10x minus 24x. So those go away. And then we're just left with that constant of 12 at the end. All right, so that right there ends up being the expression for the surface area for the rectangular prism in part B. All right, so as long as you got the formulas, you get these dimensions down, right? That's the first challenge, knowing from the wording which of the dimensions to make the variable, then getting expressions for the rest of the dimensions, and then you just have to plug it in and just be very careful with your algebra.